Hello guys, welcome back to Electrostats. Last class we discussed about what are charges, how do they behave, how charges are produced by the process of conduction and induction, and we introduced the latest part, the Coulomb's law. That was the electrical force between any two charges. Today we are going to start with electrical forces only. This electric force is given by Coulomb's law. What does it state? Definition is very simple. Consider that we have two charges Q1 and Q2 separated by some distance r. So according to definition, Coulomb's law states that force of interaction between any two charges is directly proportional to product of these charges and inversely proportional to square of distance between them. If I add these two factors, if I accumulate these two factors, what I am getting is force is proportional to Q1 Q2 upon r square. Now, to remove this proportionality sign, we always put a constant of proportionality. So here, constant of proportionality is K. These constants are always figured out experimentally. F is equal to K Q1 Q2 upon R square. This is the required formula which is given by Coulomb's law. Now, if you have not noted, I used the word interaction while using the statement of Coulomb's law. Let me repeat. Force of interaction. I'm not using the word repulsion or attraction. There's a reason behind it. I'm using the word interaction. Force of interaction between two charges directly proportional to product of these charges and inversely proportional to distance, square of distance between them, which gave me this formula F is equal to K Q1 Q2 upon R square. Now, the reason I used the word interaction is that you have got the formula. Let me give you the value of K first and then I'll explain the interaction word. Where K is constant of proportionality given by 9 into 10 raised to power 9. Unit is how, never learn the units, always derive the units as required by the numerical. For example, here I want to write the SI unit of K. What I am going to do is, keeping the K here, I am taking this R square there and Q1 Q2 there. So force, SI unit of force is newtons, distance square multiplied meter square upon Coulomb into Coulomb is Coulomb square. So this is the SI unit. So don't remember the formula, don't remember the SI unit, just derive it. Coming back to my point, why I did not use the word attraction or repulsion. Why did I use the word interaction? There is a very famous confusion in students about using the Coulomb's law in vector form. What is Coulomb's law in vector form? Or what is vector form? See, all of us know that a vector is made up of two things, magnitude as well as direction. Now, if I have to write Coulomb's law in vector form, what I'll be doing is, I have already given you the magnitude through this formula. What I'll be doing is, I will give you the direction as well in the statement and accordingly the statement will change. Do not confuse Coulomb's law and Coulomb's law with vector form. Listen to the statement. According to Coulomb's law in vector form, force of interaction between two charges separated by some distance is directly proportional to product of their charges and inversely proportional to square of distance between them, dot. Till this point, force, the formula, the equation, the sentence remains same. Followed by, and the direction of force is given by nature of charges. That is, like charges repel each other and unlike charges attract each other. This statement, this fragment of part will be added to that sentence and that will conclude your Coulomb's law in vector form. Let us come to this point. See, how we are going to follow Coulomb's law is, we have done Coulomb's law. I will tell you how to use Coulomb's law in vector form. Then we will change this formula as per requirement of the medium between the charges, and then we'll use the dielectric. That's all. This is how force, this is the method how you should do numericals about Coulomb's law. So, let's start it from the beginning. Please note down whatever points you like to note, because these videos are supposed to be in condensed format. So if you miss any point, try to pause the video and write down the note then and there. Q2, these two charges are separated by distance r. If I want to write force on 1 due to 2, now see this arrow, that means I am writing it in vector form. The vector form means I will be writing the magnitude as well as the direction. So magnitude, as the formula gives me, is k q1 q2 upon r square, and the direction, I have not mentioned any sign in front of q1 and q2, that means they are both supposed to be taken positive for now. Always, even in numericals, if they have not mentioned the sign of the charge, take it positive. If there is a negative sign, that means it is negative. Right now these two are positive charges, so they are going to repel each other. Force, this charge q1 will be repelled away from this charge q2, so this will be the direction of force on 1 due to 2. Similarly, this will be the force on 2 due to 1, right? Okay, I have written the vector form here, so this is the magnitude. Where is the direction? How will we write it? If you are not sure about what direction to write, use the unit vector r, cap. This is the unit vector which gives us the direction, and this unit vector is from which charge to which force? Is it from 2 to 1, the direction of force, or is it from 1 to 2? Yes, it is from 2 to 1. So unit vector r, 2, 1. See, there is no confusion here. F12 is the force on 1. Due to 2, this charge is getting away, getting repelled by this charge. So obviously the unit vector will be in this direction, that is from 2 to 1. So F12 is k q1 q2 upon r square r21. Similarly F21 will be equal to k q1 q2 upon r square into direction. What is the direction of 21? From 1 to 2. But from the vector conventions, we already know that if this is a vector A and I draw a vector which is equal in magnitude but opposite in direction, I can call it minus A, negative vector. Similarly, R12 is negative of R21. So I am rewriting this equation, the second equation. I am using the space here, F21. From that point, k q1 q2 upon r square. Instead of r12, I have to write minus r21. So r21 with a negative sign. This is my negative sign. This whole part becomes this, that is F12. So F21 is minus of F12. This is an equation which is the answer to a very good question. Show that Coulomb's law obeys Newton's third law of motion. This is your answer. Forces are equal and opposite in nature. Equal to sign gives equal, negative sign gives opposite in nature. Forces are equal and opposite in nature. So this whole question becomes, state Coulomb's law in vector form and show that Coulomb's law obeys Newton's third law of motion. And this is the answer. While writing the answer, you will start with the statement Coulomb's law in vector form, which I just gave you, followed by the diagram, followed by 1, 2, 3 equation, and this. That concludes it. Now, since we have done this Coulomb's law, let's come back to the original formula, and we need to formulate it for the presence of medium between the charges. There is simple change in the formula. And what was the need? Consider this is as a free space. I meet a lot of students who get confused between the terms free space, vacuum or air. And books like Pradeep, ABC, NCRT, SL Aurora, books always use these three notations for same thing. They are all equal. Let it be any other medium. Okay. Consider we have two charges Q1 and Q2 separated by some distance r. Same charges Q1 and Q2 separated by same distance of separation r. But right now these charges are placed in some other medium. Okay. So here F naught, force in the free space of vacuum, would be K Q1 Q2 upon r square. Here force in the medium will be again K Q1 Q2 upon r square, and experimentally it was seen that force was not equal to force in the medium. So where is the problem? What change do we require in the formula? Formula was absolutely right. We forgot to inculcate the presence of medium between the charges. So we changed the formula by introducing a term which denotes the medium. So the constant K, you got this point, right? Force in free space was not getting equal to force in the medium, so we had to change the formula. So instead of using K, we started using another constant whose magnitude value is same as K. K was replaced by this constant, 1 upon 4 pi epsilon naught. Magnitudes was same. Numerical value was same. The whole constant got replaced. Why? Because of this term. What is this term? Epsilon naught. This is called permittivity of free space. What is permittivity? Try to recall that small experiment we used to do when we were kids. We used to take a ruler scale and we used to rub it from here, and we tend to attract small bits of paper, right? What if you would have taken a stone and rubbed it on your hair and tried to pull the papers? In the second case, in case of stone, the paper won't have got attracted towards the stone because exactly the charges were not getting formed on the stone. But in case of plastic scale, the charges were getting formed. This is the permittivity. This is the extent of a medium up to which it allows electron to flow through them or come inside them, so that the ultimately charge is produced on the body. This is called permittivity of free space. So now our formula for the medium will be changed for, like, force in the medium will become 1 upon 4 pi epsilon m. Epsilon naught, no, epsilon m, which is permittivity of this medium, whatever the medium be. 4 pi epsilon naught, rest of the things remain same. And now the formula, after this and that, the formula was valid. So this is the final formula we will be using in all of the numerical. Okay, there is another thing that students do, which is a mistake. While writing the formula, while doing numericals, what you guys do is you always try to remember the easiest formula, which is what? K Q1 Q2 by R square. I would suggest you try to always use 1 upon 4 pi epsilon naught instead of K. That will lead to less mistakes. So till this point, how many formulas do we have? One we did in the last class, which was the quantization formula, Q equals to NE. Another one we just did, force, which is K, this is K, Q1, Q2 upon R square. Till now we have got these two formulas. And we introduce a term, permittivity. So for different mediums it will be different permittivity, the epsilon m thing. Let me show you how epsilon m is converted into dielectric constant. This is the last time we are doing it, and we'll proceed to next part. R, free space or vacuum, F naught becomes, right, same charges separated by same distance, M force in the medium becomes 1 upon 4 pi epsilon m q1 q2 upon r square. So the introduction of dielectric constant goes like this. What if you divide F naught upon Fm? You will get right? Cancel out all the common things. 1 upon 4 pi got cancelled out, q1 q2 upon r square got cancelled out. You are left with 1 upon epsilon naught over 1 by epsilon m, which will invert itself while going to numerator. So ultimately you are left with f naught upon fm is equal to epsilon m upon epsilon naught, right? This is known as, don't confuse this k with the previous k. The previous k was the whole constant used in Coulomb's law, which was equal to 1 upon 4 pi epsilon naught, numerically equal to 9 into 10 raised to power 9. This k is called dielectric constant or relative permittivity. Or do one thing, write this k in some different format. Use some other Latin k, but use it in different format. So you will remember what this k stands for. This is called dielectric constant. And how would we use it? Suppose this medium which we did here was water. This medium is water, H2O. So we know that dielectric constant, I'm using the another k, let me rewrite it like this, is 81. So in case while I was doing the formula, if I noted it down, I'm rubbing it off. While we were doing this formula, I would have rewritten it as 1 upon 4 pi. Instead of epsilon m, what I can write? Epsilon m is equal to k times epsilon naught. So instead of epsilon m, I am writing k times epsilon naught q1 q2 upon r square. Out of this, 1 upon k is separate. 1 upon 4 pi epsilon naught q1 q2 upon r square. This whole thing is this F naught, the original force. So net force in the medium Fm is equal to 1 upon k into this thing, that is F naught, or F naught upon k. So the whole force got divided by k. That means if there are two charges, for example, if these two charges are repelling or attracting each other with a force of 100 newtons, in case of water, the force will get divided by the dielectric constant of water, which is 81. So 100 upon 81. Simple? Yeah, we did not miss any point. So this dielectric constant comes in your exam in case of definition in these two formats. Define dielectric constant in terms of force or define dielectric constant in terms of permittivity. This definition is still easy. Why? See, dielectric constant of a medium is defined as the ratio of permittivity of the medium to the permittivity of free space. Simple word, simple use, permittivity, space, medium, that's all. Dielectric constant of a medium is defined as the ratio of permittivity of the medium to the permittivity of free space, that's all. But in case of force, you have to mention charge, distance, medium and space. So the definition for this case will be dielectric constant between two charges separated by some distance in free space is defined as ratio of force between those charges separated by distance or separated by some distance in free space to the force when same charges placed at same distance of separation are kept in that particular medium. That's all. Finally, the last topic for the force is the superposition principle, which is very easy as such in topic, but sometimes a bit confusing for students to understand the basic gravity of what exactly superposition principle is about. We'll do it in a very simple way. Superposition principle means Consider this plane, the whiteboard. We have a small charge q naught at the origin. At distance r1, let us say there is a charge q1. At distance r2, q2. Distance r3, q3. The net force of, for example, suppose q1, they are all positive. Suppose q1 is repelling this charge with a force of 2 Newton, this with 3 Newton, this with 4 Newton. So the net force will not be equal to 2 plus 3 plus 4. No, will not be equal to. That is what superposition principle is about. Superposition principle states that net force on a charge due to group of charges is always equal to vector sum of individual forces. Again, superposition principle states that what net force on a charge due to group of charges is always equal to vector sum of individual forces. That is, F would be equal to F1 plus F2 plus F3 and so on if there are more charges. When there is this thing, vector addition, what do? Q1 and Q2, let say that the force F1 is in this direction. Let us say the force F2 is in this direction. So firstly, you will find the resultant of F1 and F2 considering the angle between them. Whatever the angle be, find out the resultant using the old vectors resultant formula. What is that? A square plus B square plus 2AB cos of theta. Using this formula, find the resultant of Fn and F2. Once you have Fn and F2 resultant, which is F12, then you have F12, then let us say this force, the F3 was in this direction. Find the resultant between F3 and F12. This will give you the ultimate net force. If it is still confusing to you, let us do some examples, and that will conclude your topic of Newton's, of this Coulomb's force. I just named Newton somehow. So can anyone please suggest 2 points of difference and 2 points of similarity between Coulomb's force and gravitational force? Think. By the time I am drawing this diagram, think. The points of similarity are both are central forces and both obey inverse square law. What was inverse square law? 1 upon r square. Whichever is proportional to inversely proportional to distance ka square, that obeys Newton's that obeys inverse square law. And the point of dissimilarities are that Coulomb's force could be attractive as well as repulsive, but gravitational force is always attractive. Second point, the force in that case depends on mass, while in this case depends on charge only. Simple. Try to do as many numericals from this electrostats first part, that is Coulomb's law, because that will help you with electric field, electric potential and everything. Even in upcoming chapters like magnetic field, lot of things. This particular numerical, I am giving you the task of find the net force on this 1 microcoulomb charge due to these two charges. This is an equilateral triangle of side 3 cm. There are 2 ways to do this numerical. I am teaching you both the ways and try to put both the ways in my next numerical. See. This 3 microcoulomb charge will repel this 1 microcoulomb charge, right? So this charge is, suppose if you don't consider that this is even in the picture, How will this charge behave? This is repelling this charge, so it will go away, right? This is the force on this particular charge due to this. Now, while writing these such kind of things, you have to make it simple. While representing your answer in board papers, you have to make it very simple so that examiner, while checking your answer, understand it easily. One of the easiest method is name the points A, B, C. So this is the force due to particle present at A. Simplest form. Fa means particle present at A, it is applying this force. This 3 microcoulomb charge is going to attract this charge. So force due to particle at B. Simple. This was negative, that is why it is attracting. This was positive, that is why it is repelling. Very simple. First method is, I find the value of Fa, I find the value of Fe separately and I do the resultant. For Fa, Q1 equal to 1 microcoulomb. Whenever you write these values while doing your paper, never write this what I just did. Q1 is equal to 1 microcoulomb, somehow you will mistake. Write Q1 equal to 1 into 10 raised to the power minus 6 coulombs. This is the right way of writing. Q2 3 into 10 raised to the power minus 6. And if some of you are still thinking, why did I take Q1 as this and Q2 as this? Why can't I take Q1 to be this and Q2 to be this? Take whatever, both are right. Distance is equilateral triangle 3 centimeter, that is 3 into 10 raised to the power minus 2 centimeter meter. So put the formula. I told you do not use K Q1 Q2 by R square.